Okay, so today I'm going to talk about naming amines. I've already done this in a previous lesson, but I was doing common names. Today we're going to do, or in this lesson, I'm going to do IUPAC names. So just to review, in case you haven't looked at the other one, an amine is an organic derivative of ammonia. So ammonia normally looks like this. And we replace one of the hydrogens with an R group, with an alkyl group, or it could be a cyclo, or there's a lot of things it could be, but an R group, a carbon chain, something like that. Now there's three types of amines, really. There's primary amines, so that's what I actually just drew. It's where we've got one R group attached and two hydrogens all attached to the nitrogen. A secondary amine is where we have two R groups and one hydrogen. So it's two R groups, the primary, secondary, and then finally tertiary are just telling you how many R groups are attached to the nitrogen directly. So tertiary is 3 R groups. Here's a little bit better picture of the three types. And they can have a lot of different forms. These are the generic ones with the R's. So naming amines, I'm going to start with just naming primary amines, and I'm going to get a little more advanced from there. Naming primary amines it actually becomes like alcohols or like ketones or something. We just identify where the nitrogen is. So this is in definite contrast to the way we think about naming by common names. In common names, you think about the nitrogen as sort of the center of the atom and the center of the molecule and the parent, and where you do all the naming from, and everything attached to the nitrogen is a substituent. In the case of IUPAC, this is a lot like the naming ether difference between common and IUPAC, that the common names, or sorry, the IUPAC names, we don't actually start from the point of the nitrogen. We actually still find the longest parent chain. So I'm mostly just going to talk about this. So I find the longest parent chain. So this is this one chain here. So we're looking for the longest carbon chain. So 1, 2, 3, 4, 5, 6. Now we want a number starting from down here. 1, 2, 3, 4, 5, 6, because we want the nitrogen attached at number 3, carbon number 3 instead of carbon number 4. So this is simply a matter of we say 3 hex to indicate that the longest parent chain is 6 carbons long. Hex N amine. So we drop the E from the end of hexane, and we add amine on the end. So the 3 indicates where on the chain it is. So it's important to understand you don't start numbering at this carbon. There's this tendency to want to start numbering where the nitrogen is attached. But that is not how we do it. We find the longest carbon chain, and we indicate where along that chain the nitrogen is attached. Any other substituents are dealt with exactly as normal. So if I had something more like this, okay. Again, we find the longest carbon chain, which I made fairly easy to find. So it's right along here, right? It's right in here. We want to start numbering from the end nearest the nitrogen. Remember, the alkyl groups get the lowest priority, so we start closest to the nitro group there. So 1, 2, 3, 4, 5, 6, 7, 8, 9 it actually is. So that means that our parent chain name is going to be non-amine, right? But we also have to indicate where the nitrogen is attached. So it's attached, you can see it, carbon number 4. And the other substituents are just dealt with as exactly as normal. So we have an ethyl group at 7 and 2 methyl groups at 4 and 5. So alphabetically first comes the ethyl group, so 7, ethyl, 4, 5, dimethyl, 4 non-amine. So again, this 4 indicates where the nitrogen is. And here are the written out directions, so you can see them a little bit better, more clearly. So you name the parent chain by adding. So find the longest carbon chain, name it as normal, but you drop the E at the end and put amine on the end. So methanamine, ethanamine, propanamine. Number the parent chain nearest the nitrogen atom. Indicate the number where the carbon number where the nitrogen atom is attached, and then identify any other substituents. So primary amines are fairly simple. Now you think, well, that's easy, but what happens if I have, say, a nitrogen? So here, actually I didn't talk about this let me do one more example here. So this is a simple one, and common naming, it would be very simple, but when we do IUPAC naming, we have to identify that this is the longest carbon chain. We have to start numbering nearest the nitrogen, so we go 1, 2, 3, 4. So we have to call this 1-butanamine. Common naming, we would call this butylamine, but this is 1-butanamine. If we have something, you may say, well then, great, but what if I have a nitrogen with something like that, and then another group attached? How do I handle that? Well, what we do is we follow the same procedure. We still find the longest carbon chain, which is this one. So that is 1, 2, 3, 4. Again, I should point out, just like with we have oxygens, the length of the carbon chain is just the carbons. The nitrogen is not included in that, is not part of that math. And I want to make sure this doesn't look like a methyl group. So we would, ignoring this group over here on the right, we would just call this 1-butanamine. Now, the way we treat something that's a substituent off of the nitrogen, we just treat it like it's a substituent. We would just put in front, we'd put ethyl. But to indicate where it is instead of a number, we put N. I didn't draw that very well. Put N, so it'd be N-ethyl 1-butanamine. So it's just a functional group like any other functional group, or not a functional group, it's just a substituent like any other substituent. It's just that it's on the nitrogen. That's the only real difference. And we don't treat it really any different in the way we name it. A couple more examples here. So it's supposed to be a methyl group. So again, longest carbon chain pretty clearly right here. 1, 2, 3, 4, 5. So we're going to call this 1-pentanamine. But now notice we've got a methyl group on the nitrogen and a methyl group on the parent chain. We number them, we deal with this just like they were, together. We put them together as dimethyl. So I'm going to call this 3N-dimethyl 1-pentanamine. The 3 comes before the N alphabetically because when you alphabetize, numbers come before letters. And that's really the only reason. Otherwise, you treat any substituent on the nitrogen group like it's a substituent on the parent chain. You don't separate them. You don't prioritize anything with an N any higher. You just do it by alphabetization. So, for example, let's get another example up here. So it was like this. We go 1, 2, 3, 4, 5. Actually, I'm going to make it a little more interesting. I'm going to change it here. I'm going to make this like this. So now if we look at the chain, you may be tempted to say that this is a 5-carbon chain here with a methyl group. But in actuality, remember, we're finding the longest carbon chain. We're not starting at the nitrogen. I can't emphasize that enough. Don't start numbering where the nitrogen attaches. We start here, 1, 2, 3, 4, 5, 6. So this becomes, so here now we have an ethyl group and a methyl group. So this becomes 4 ethyl N methyl. Oh, forgot one thing. Forgot my number indicating where the nitrogen where the nitrogen is. So 2 hexanamine. Can't quite get it in there. 2 hexanamine. So there it is. Now you may say, well, what about tertiary? Tertiary amines? Well, if I have another methyl group here, which would mean that we don't have the nitrogen anymore, this would just become 4 ethyl N dimethyl 2 hexanamine. So that's the main thing I want to emphasize is you find the longest carbon chain. You don't start at the nitrogen, and everything else is just a substituent. Substituents can happen to be on the nitrogen. You just indicate that with an N. You don't separate them. You don't prioritize them higher. You don't do anything differently. You lump them all with everything else. And when you alphabetize, or when you put things in numerical order here, you do it numerical and then by the letter. So here are my directions, secondary and tertiary amines. Don't really worry about amines with other functional groups or diamines for now. If you want to read that and you want to look into that, that's fine. I'm just going to stick with primary, secondary amines. So here's the directions. Names of other groups attached to the nitrogen are appended to the front of the base name, just like any other substituent. So here are some examples. Notice that here, this is our longest parent chain. So this becomes, so we number from here 1, 2, 3, 4. So this is just 2-butanamine. Here, this is another 2-butanamine, numbering from this side this time, but it becomes N-methyl-2-butanamine. Here, on the bottom left, our longest parent chain is here, and we have 2N indicating at carbon. Now, I number from this side because the nitrogen is going to be number 3 no matter which way I go, so I prioritize that methyl group here. So there's a methyl group at carbon 2, there's a methyl group on the nitrogen, and then the nitrogen is attached to the 5-carbon parent chain at carbon number 3. Don't worry about this. This has to do with that whole thing about priorities and how how to name it if the nitrogen is not part of the highest priority. I should say this does bring up a point. Sort of like an alcohol's functional group is called the hydroxyl group, an NH2 or an NHR group or an NRR group. These are called amino groups. It's an amino group. I'll finish up here by just letting you guys try the names. I believe we did these in class, but let's go ahead and try them again. So here we go. Go ahead and pause it and try to do these. I will go ahead and do this diamine one here, but I'm not going to hold you responsible for it. So the first one up here, this is my longest parent chain, and I can number from either way, 1, 2, 3, 4, 5. So this is just 3-pentanamine. This one is a 3, nope, I did that wrong. It's an N-methyl 3-pentanamine. There we go. And then here's another. Now this is, so number 1, 2, 3, 4, 5. This is 2-methyl 3-pentanamine. This one, I'm going to go down to the bottom first, and then I'll do the one on the right here. So on the bottom here, this is, the parent name is going to be 1-butanamine. And then we have, in front, we have dimethyl. and they're both attached to the nitrogen, so it's N-N-dimethyl. Up here, we call this is a 5-carbon parent chain. There's a nitro group at each end. We call it 1,4-pentane diamine. That's how we handle that. Okay. I hope that helps with the naming of the IUPAC naming of amines.